Okay, today we're going to be covering 8.4 in your book, which is dealing with proportion hypothesis testing, or for short, p-tests. So a couple of differences between the hypothesis testing process that we've been working with for means lately and the new ones that we're going to be discussing today for proportions. First of all, we want to make sure that we're hypothesizing about population proportions instead of means. So the null and alternative hypotheses need to be written in terms of the population proportion P. Next, we need to make sure that in our summaries, we are referring to that population proportion and not the mean again. So summarize about the proportion that we're given. The last major difference is the formula that's used to find the test statistic. This is step number 3 of our process. We're going to be using this formula that we see here. Z equals P hat minus P divided by the square root of P times Q over N. P hat, remember from confidence intervals, is the sample proportion. The regular P is the hypothesized population proportion. Q is always the complement of P. So if the hypothesized proportion is, let's say, 40%, our Q would be 60%. So they always add up to 100% or 1. And then divided by N, N is the sample size. Okay, we're going to go ahead and take a look at the first example together. In a study of airbag effectiveness, it was found that 821 crashes of mid-sized cars equipped with airbags, 46 of the crashes resulted in hospitalization of the drivers. Use a 0.01 significance level to test the claim that the airbag hospitalization rate is lower than 7.8% for crashes of mid-sized cars. Okay, so for our first step, we're going to write the null and alternative hypothesis. So these are going to be in terms of P, the proportion. So notice that here is our proportion. I'm going to change that to a decimal. So P equals 7.8% or 0.078. The alternative, we're looking for an indicator in the prompt that indicates a direction. We see lower. So P is less than 0.078 is our alternative hypothesis. Step number 2, we're still going to draw out that distribution. Since we're testing a less than alternative hypothesis, I'm going to shade the left tail. The alpha level given in the prompt was 0.01. To find that critical value, we're looking back on the Z chart for proportions, always the Z chart for proportions. And we're scanning that negative Z chart for the closest probability that we can get to 0.01. You should see a Z value of negative 2.33. That is the closest Z value associated with a probability of 0.01. So that's our critical value. Step number 3, we're going to use that formula to find the test statistic. So the first thing we have to do is find P hat, which is the sample proportion. So in the prompt, it told me that 46 people required hospitalization after a crash out of 821 crashes. So let's go ahead and find what that is as a decimal. So 46 divided by 821. This will give me P hat, which P hat is approximately 0.056. Okay, so plugging that in for P hat, 0.056 minus the hypothesized proportion of 0.078 over the square root of P, 0.078, times, let's go ahead and find Q. So if we take 1 minus 0.078. That would be the complement of P. In other words, Q is 0.922. And we're dividing that by N, which is the sample size 821. Guys, there's lots of room for error if we were to try to calculate that by hand. So instead, I'm just going to jump to the calculator function. The calculator function for this one, if we go to stat and over to tests, it is option number 5, one prop z-test or one proportion z-test. Go ahead and enter that. Our null hypothesis is 0.078. Our number of successes, X. In this case, the number of people who required hospitalization was 46. The N is 821, so that's the sample size. And the alternative hypothesis is the less than scenario. So I'm going to highlight that less than case and calculate. The calculator is going to tell me the p-value and also the z-test statistic. So our z-test statistic is 2.35 if I round that to 2 decimal places. The p-value for this one is 0.0095, I guess, if I round that up. Now be careful, guys. Here's a p, right? That's standing for the p-value, and then p-hat. P-hat is our sample proportion. So that's what we got earlier when we took 46 divided by 821. All right, we have to make our decision. So we can make that decision 2 different ways. We talked about this earlier, but just to recap, you can put your test statistic on the graph to make the decision. So negative 2.35. Remember, the middle line has a z-value of 0. Our critical value started at negative 2.33. So negative 2.35 is just going to be slightly to the left of that. That is in the shaded region. That's our rejection region. We can also make the decision by comparing the p-value to the alpha level. So in this case, our p-value is 0.0095. Our alpha level is 0.01. So p is less than alpha. Here's a little rhyme to help you remember the decision. When p is low, that means lower than the alpha. When p is low, reject the hoe. So we are rejecting the null hypothesis for our decision. We still have to write a summary for these guys. It's still a 6-step process. Unfortunately, I'm not going to have room on this slide to write it, so I'm just going to say what the summary statement would say in this case. So at alpha equal to 0.01, there does seem to be evidence to support that the airbag hospitalization rate is lower than 7.8% for mid-sized cars.